A particle P is projected from a point 5 meters above the ground. The vertical and the horizontal component of the velocity are 24 meters per second. The question says find the value of angle theta in degrees and the distance OQ, that is from the foot of projection of the particle to point Q, where the particle hits the ground. Now in this question, it's also a projectile question. The particle is projected. This is the particle at point P here. This is particle P projected at this point. Now this point is already raised above the ground, 5 meters above the ground. And then the particle is shot up or projected with a speed of, which is not given, so we'll call that speed v. V is the initial velocity of the particle, meaning that if v was known and then we resolve v into two perpendicular components, we'll have got 24 meters per second, the component of v acting horizontally, and then 24 meters per second, the component of v acting vertically. That means this 24 meters per second is my ux, and this other 24 meters per second is my uy. How did I define ui and ux in the previous videos? I say ux is the horizontal component of the particle's initial velocity. The uy is the vertical component of the particle's initial velocity. That is, when we resolve the v, we have this component acting vertically and this acting horizontally. So, and in the other video we said ux is the same thing as u cos theta, but since my initial velocity is v, there's a change of variable here. Sometimes we use u as initial velocity, some other time we can use a different variable. That should not confuse you. So we have v cos theta, and then my uy is u sine theta. That is, I can change that u to v, that is v sine theta. Okay, so come back here now. Ux is this, which is 24, meaning that ux is already given. The horizontal component of the particle's initial velocity is this, and this one is this. So that when I divide the two equations, dividing equation 2 by 1, I have v sine theta over v cos theta equals, on the right hand side, 24 here and 24. So v here cancels out v, and 24 cancels out 24. That gives us 1. That means the ratio sine theta over cos theta gives me tan theta equal to 1. Now if tan theta equals 1, then what's theta? Theta here, which is the angle of projection, will be equal to the tan inverse of 1. I'm sure you know how to find this value from a calculator. Use the shift function. So the tan inverse of 1 is 45 degrees. That's the angle of projection. So that solves the first question we have to find, but to find theta, which is the angle of projection. Now the second part of the question says we should calculate the distance OQ from this point here, the foot of this point of projection of the particle, to the point Q, where the particle hits the ground. Now again, we are going to use the vertical component, the vertical parameters of this projectile motion. Now again, when the particle passes this point here, let me call this point R, it's at point Q, it is now 5 meters below the ground, which means from this equation, y equals ut sine theta minus gt. I can find the time taken for the particle to hit point Q. If I get the time taken for the particle to go all this while and strike this point Q, then I can determine this horizontal distance from point O here to point Q. So at point Q, y equals minus 5 because it's already 5 meters below the reference level, which is the plane of projection. Okay, so that gives me my u sine theta, because this is also y equals u sine theta times t minus minus half, there's a half here, minus half gt squared. Now this u sine theta was already given. My u sine theta was given as 24. So I put minus 5 equals 24t minus half times 10 times t squared. This gives me minus 5 equals 24t minus this is 5t squared. Now, by the time I rearrange this equation, I want to take all these two terms, I want to bring them to this left-hand side of the equation. I have 5t squared is now positive. If I bring this 24t to the left-hand side, it becomes minus 24t, then minus 5 equals 0. This is a quadratic equation, and we can solve it by factorization. And in that case, I can use the algebraic equation. This is A, minus 24 is B, and minus 5 is C. So I'll use T equals minus B plus or minus square root of B squared minus 4AC divided by 2A. That gives me T equals minus 24 plus or minus square root of my B is minus 24 squared minus 4 times A, that is times 5, times minus 5 divided by 2 times A, which is 2 times 5. That gives 10. Okay, so that my T equals, this is 24, minus times minus, plus or minus square root of 24 squared is 576, plus the product of this minus times this minus makes this positive. So 4 times 5, 20, 20 times 5 gives me 100 divided by 10. Okay, 10. So that T now equals 24 plus or minus square root of 676 divided by 10. So I'll find the square root of 676. That gives me 26. So that my time t is 24 now, plus or minus 26 over 10. So I'm going to take the first value because time t cannot be negative. So I'll take the first value, positive, which is 24 plus 26 divided by 10. So it takes, this is 50 over 10. That gives me 5 seconds. So it takes 5 seconds. That is the total time of flight for the particle to go from the point of projection to where it hits the ground at point Q. Now that will enable me to find the distance OQ. Recall the question says we should find distance OQ. So distance OQ, we use this equation for horizontal projectile. Distance OQ, that is my x, equals ut cos theta. That is x equals u cos theta times t. This t is the time of flight. We'll call that time of flight. The total time taken for the particle to go from the point of projection to the point Q here. And we have calculated that as 5 seconds. It takes 5 seconds to do that. So that my distance OQ, that's my x, I call that OQ, is equal to u cos theta has already been given as 24 times t, which is 5. That will give me 120 meters. So that's the distance OQ for this particular question. So we'll see more questions in the next video still in this topic. Thank you for watching.